Section 8.2 is about using the quadratic formula to solve quadratic equations. So the solutions of a quadratic equation in standard form, ax squared plus bx plus c equals 0, and a not equal to 0, because if a was 0, then it'd be a linear equation. We couldn't use the quadratic formula, are given by the following formula. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And a lot of people sing it to the tune of Pop Goes the Weasel, just so you know. And what's nice about the quadratic formula is we can use this to solve any quadratic equation, even when the solutions are irrational or complex. And a lot of people prefer it to completing the square. To find those irrational solutions. So what I would still recommend though when given a quadratic equation is you try and solve it the old way, because the old way in my opinion is a little bit faster and less clunky. So let's factor x squared plus 5x plus 6 equals 0. The old way, by that I mean finding the factors of AC that add up to b, and then we'll use the quadratic formula. So I have x squared plus 5x plus 6 is 0. So my AC is 1 times 6, which is 6, and my B is 5. Well, what are the factors of 6 that add up to 5? That's 2 times 3. So I can rewrite this, because my leading coefficient is 1, as x plus 2 times x plus 3 is 0. So I have x plus 2 is 0, and x plus 3 is 0. So I get x is negative 2 and x is negative 3. That was not so bad, right? So when I approached solving quadratic equations, I always try to find the factors of AC that add up to b, because it's a little bit clunky to use the quadratic formula, and I'll show you what I mean. So I have a is 1, b is 5, c is 6, and all I'm going to do is substitute in to the quadratic formula. So I have x equals negative b, which is a negative 5, plus or minus the square root of b squared, which is 5 squared, minus 4 times a, which is 1, times c, which is 6, all over 2 times a, which is 1. So I get x is negative 5 plus or minus the square root of 25 minus 24 all over 2. So I get x is negative 5 plus or minus the square root of 1 over 2. So I get negative 5 plus or minus 1 over 2. So I have x is negative 5 plus 1 over 2, and x is negative 5 minus 1 over 2. That would give me negative 4 divided by 2, which is a negative 2. This would give me negative 6 divided by 2, which is a negative 3. So see how it's a little bit clunkier if we could have used the old way, but the old way doesn't work if we can't find factors of AC that add up to b. So that's when we're going to use the quadratic formula. So let's work through an example. First thing you always need to remember is that the equations must be in standard form. So I always want to start by labeling my ABCs. In this case, A is 6, B is negative 5, and C is negative 4. I have x is negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that means x is negative 5 is a positive 5, plus or minus the square root of 25 minus a negative 4 times 6 is a negative 24, times a negative 4 is a positive 96, all over 12. X is 5 plus or minus the square root of 71 over 12. So x is 5 plus the square root of 71, which is prime, and I can't simplify, over 12. And x is 5 minus the square root of 71 over 12. Remember, the answers are conjugates. So I have 4x squared equals 8x minus 1, and the first step in this case is we need to get it into standard form. Otherwise, our terms will have the wrong sign and our quadratic formula will be incorrect. So I'm going to move everything over to the left. So I have 4x squared minus 8x plus 1 is 0. And now is when I'm going to play with my ABCs. So A is 1, B is negative 8, and C is a positive 1. So x equals negative b, so a negative 8, plus or minus the square root, negative 8 squared minus 4 times a times c, all over 2a. So x equals 8 plus or minus the square root of 64 minus 16, all over 8. So x equals 8 plus or minus the square root of 48 over 8. And 48, that factors into a 4 times 12, which is a 4 times 3, 2, 2, 2, 2. So I get to pull out a factor of 4. So then we're going to have 4 square root of 3. So I have x equals 8 plus or minus 4 square root of 3 over 8. And I can simplify this by pulling out a factor of 4. So I have x equals 2 plus or minus the square root of 3 over 2 for my final answer. Again, let's practice solving this using the quadratic formula. The first thing I need to do is get this into standard form. So I have 9x squared, once I FOIL this out, minus 9x plus 3x minus 3 is 8. I have 9x squared minus 6x minus 3 is 8. I subtract 8 from both sides. I have 9x squared minus 6x minus 11 equals 0. So now I have my A, B, C's. And then we'll go ahead and solve this using the quadratic formula. So I have x equals a negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I have x is 6 plus or minus the square root of 36. Negative 4 times 9 is negative 36 times negative 11. It becomes a positive 396. Oh, good grief. Over 18. So I have x equals 6 plus or minus the square root of 432 over 18. $432 is 12 squared times 3. So I have 12 times 36. 12 times 3. So I'm going to be able to pull out a factor of 12. So I have x equals 6 plus or minus 12 square root of 3 over 18. I can pull out a factor of 6, so x is 1 plus or minus 2 square root of 3 over 3 for our final answer.